Hey guys, it's Mrs. Kerr again. So today's lesson video is on solving rational equations. So what I'm going to do first is kind of outline the steps that we'll be doing when we solve them, and then I'll do a few examples. Keep in mind that this very much builds upon the prior lesson, which is on adding or subtracting rational expressions. And you can see that with the steps here, because our first step is to get a common denominator for all fractions in the equation. So as I mentioned that we talked about in the previous video with the solving. And then you're going to want to multiply both sides of the equation by the common denominator, and this is going to get all the fractions to cancel out. And then once you've done that, basically you're just going to be left with a normal linear equation, and you're going to solve and check it. And one thing you're going to want to watch out for with these is what we call excluded values. Okay? And we talked about these, I think, when we did the, started the rational expressions, but excluded values are values that would make the denominator equal to 0. Because if you get one of those as a solution, it can't be a solution to the equation. So again, these are the basic steps, and then we'll go through some in detail, and I'll be referencing these steps. Okay, so here's our first example. X minus 5 over 5 plus x over 4 equals 8. So as we said in the steps, our first step is to get a common denominator for all fractions in the equation. So this guy doesn't have a denominator, so I'm going to throw him over 1. So I have 5 and 4. So my common denominator, 5, 4, and 1, the smallest number those all go into, would be 20. So I'm going to make these all be over 20. Okay? So this is 5, so I'm going to need to multiply it by 4. Remember, got to do it to the top and the bottom. This one is over 4, so I'm going to multiply it by 5 over 5. And this one's over 1, so I'm going to multiply it by 20 over 20. Okay. And then I'm going to multiply. So let's get in a different color here. So the denominator is 20, and then here I'm going to need to distribute in the numerator. So this is going to become 4x minus 20. Okay, and then this is 20, the denominator. And then here this is just 5 times x, so this is just 5x. And then here, denominator is also 20, and then 20 times 8 would be 160. So some of you may see this and be like, oh, I should just simplify this. Leave it as it is, because now you can see you have a common denominator of 20 everywhere. So what am I going to do from here? Well, if you notice all the denominators are 20, this is an equation. So I can do whatever I want as long as I do it to both sides. So what am I going to do? I'm going to multiply both sides of my equation by 20. So this by 20 and this by 20. Okay, you're essentially multiplying everything in the equation by 20. What does that allow you to do? Cancel out the denominators. Okay, because it's divided. Remember, a fraction's really division. This is really divided by 20, and then I'm multiplying it by 20. So that's just going to leave me with 4x minus 20 plus 5x equals 160. And now this is just a normal linear equation that I can go and solve how I've always done. If you want to, you can combine the like terms first. So 4x plus 5x is 9x minus 20 equals 160. And then I want to get the x by itself, so I'm going to add 20. So that leaves me with 9x equals 180. And then I want to solve for x, so I'm going to divide both sides by 9. And 180 divided by 9 is 20. So my answer is x equals 20. And then only thing you want to check at the end is make sure that this value of 20 wouldn't make any of your denominators equal to 0. And it wouldn't. My denominators are all numbers, so there's no way they'd ever equal 0. And if I wanted to, I could simply check my answer by plugging 20 back in. Okay. So I could plug, so just showing you the check step. Okay, I won't show this on every problem, but for the check step, I'm just going to plug 20 in for x. So that would turn into 20 minus 5 over 5 plus 20 over 4. And I want to check to see if that equals 8. Okay. So 20 minus 5 is 15. 15 divided by 5 is 3. And then 20 divided by 4 is 5, and 3 plus 5 equals 8. So it does check. Okay. And again, you don't need to, I would suggest, just going back and checking it if you're not sure, but you do need to for sure make sure that your solutions will not make the denominators equal to 0. Okay. All right, let's do another example. So this one says solve, and then we have 5 minus 2x over 2x minus 1 over 6 equals 7x plus 2 over 6x. So my first step is to get a common denominator, CD. So none of my denominators are going to factor here. So I just kind of look at them. I see a 2, a 6, and a 6. So the common denominator between those three numbers would be 6. So my common denominator is 6. And then I also need to include that x. Okay, so my common denominator would be 6x. I need to make all my denominators be 6x. This one's 2x right now, so I'm going to multiply it by 3 over 3. This one just has a 6, so I'm going to multiply it by x over x. And then this guy, I get to leave him alone because he's already over 6x. So now I'm going to go ahead and do the multiplication. So this becomes 6x. And then don't forget to distribute in your numerator. So this is going to become 15 minus 6x. And this is a 6x, the denominator. And then here, this is x times 1, so this is just x. And then this guy, I'm just going to bring him down because he stays the same. Okay. So I have all of my denominators are 6x. So remember, the next step is this is an equation. You can do whatever you want as long as you do it to both sides. So I'm going to multiply everything in my equation by 6x. Okay, again, why am I doing that? It allows all the denominators to cancel. And then I'm just left with 15 minus 6x minus x equals 7x plus 2. Okay, now it's a normal linear equation and I can just solve. So let's see, let's combine these together maybe. So this is negative 6x minus x, so this is negative 7x. So 15 minus 7x plus 2. And then however you want to do it from there, you want to get all the x's together. So I'm going to add 7x. So I get 15. And then 7x plus 7x is 14x plus 2. And then I want to solve for x, so I'm going to subtract 2. So I get 13 equals 14x. And then I want to get x by itself, so since this is connected by multiplication, I'm going to do division. So I get x equals 13 over 14. Okay, which you may be like, how can that be the right answer if it's a fraction? But remember, it's not always going to work out to be a nice answer. Remember, you do want to go back and check in your original problem, make sure 13 over 14 wouldn't make any of your denominators 0. And if you look at your denominators, the only excluded value you would have would be 0. The only value that would make any of these denominators 0 is if x was 0. So you are good to go there. Okay, let's do another one. Okay, so this one we're going to solve again. We got x plus 2 over x squared minus 25 plus 3 over x minus 5 equals 5 over x plus 5. So my first step is to get a CD, a common denominator. So remember, to get a common denominator, if it's possible, you factor your denominators. X squared minus 25. Hopefully that kind of looks familiar to you. If you're saying difference of squares in your head, you're right. This is the difference of squares. So I'm going to factor this to x minus 5, x plus 5. This guy will not factor, this guy will not factor. So remember, my common denominator has to include each factor that's different. So my common denominator is going to have to include an x minus 5 and an x plus 5. So now I want to make all my denominators be that, x minus 5, x plus 5. So this guy, he's already good to go. So I'm just going to bring him down. So it's x plus 2 over x minus 5. Okay, and you can just leave your denominators factored just like we did with addition or subtraction. There's no need to multiply that out. And then this guy is going to need to be multiplied. He has x minus 5, but he does not have x plus 5. So I'm going to multiply him by x plus 5 for x plus 5. Okay, denominator, I'm leaving factored. Okay, and then the numerator, I'm going to multiply out, so I'm going to have to distribute that 3. So this is going to become 3x plus 15. And then over here, this guy only has x plus 5. He's missing x minus 5, so I'm going to multiply him by x minus 5 over x minus 5. Okay, so he stays x plus 5. X minus 5 is the denominator, and then the numerator, I'm going to go ahead and distribute that 5. So this is going to become 5x minus 25. Okay, so now I have the same denominator on all of them. So remember, now I do the magic. I multiply both sides by my denominator. So in this case, I'm going to multiply both sides by x minus 5, x plus 5. Okay, so I'm going to do that here and here. It's going to wind up canceling all my denominators. Okay, and now I'm just left with my numerator, so I'm going to go ahead and write those out. I have x plus 2 plus 3x plus 15, and then it equals 5x minus 25. Okay, so let's just kind of clean this up a bit. Let's combine like terms. So x plus 3x, so that's going to give me 4x, and 2 plus 15, that's going to give me 17. And then this is 5x minus 25. There's no like terms to combine on that side. So now I want to get all the x's together, all the numbers together. So what I'm going to do is I'm going to subtract a 4x, because then that's going to leave me with a positive x over here. So I have 17. This is going to be x minus 25. And then I'm just going to bring that 25 over. So it's being subtracted. So I'm going to add it. So then 17 plus 5 is, or 17 plus 25 rather, is 42. So I get x equals 42. And again, what you want to check for is if you go back to the original problem, if I plugged in 42, would it make any of my denominators 0? It would not. So I am good to go. Okay. And we are going to do one more example. Okay, and what I would encourage you to maybe do with this last example is write it down and kind of try it on your own first. And then you could pause the video, and then you could continue watching the video and see how I solve it. That's just my suggestion. So, okay, so we want to get a common denominator. So remember, first we have to factor our denominators. So let's see here. This guy's a trinomial. A is 1, so I need factors of 6 that add to negative 5. So that's going to be what? Negative 3 and negative 2. So this factors into x minus 3, x minus 2. This won't factor, and this won't factor. Okay. So now my common denominator has to include each factor that's different. So it's going to have to include an x minus 3, and it's going to have to include an x minus 2. So now I need to make all my denominators be that. So this guy, he's good to go. So I'm just going to recopy him. So it's 5x plus 8. And leave it factored, x minus 3, x minus 2. Whoops, it's not, that's a minus, not a negative. And then this one has x minus 3. It's missing x minus 2. So I'm going to multiply this guy by x minus 2 for x minus 2. Okay, denominator's x minus 2, x minus 3. And then in the numerator, I'm going to go ahead and distribute. I'm just going to leave that negative there for now. So I'm just going to just treat this as a 7. So this is going to become 7x minus 14. And then this guy, he only has x minus 2, so he's missing x minus 3. So I'm going to multiply him by x minus 3 for x minus 3. Okay, keep the denominator. And then the numerator, I'm going to go ahead and distribute. So that's going to become 4x minus 12. Okay. So that's where I'm at right now. So one thing, this is the type of problem where you have to be, this is where we tend to make a mistake. This negative, remember, applies to both of these guys. So before I go ahead and cancel out my denominators by multiplying. I'm going to kind of do like I did when I did just a regular subtraction problem. I'm going to turn this into a plus, and I'm going to switch the signs of both of those. Okay, I'm going to do that before I multiply by the common denominator, because otherwise if you multiply by the common denominator, you're likely to just make the 7x a negative, okay, when that negative applies to this and to this. So now I'm going to go ahead and get my denominators to cancel out. So I'm going to multiply this side by x minus 3, x minus 2, and I'm also going to multiply this side by x minus 3. Okay, denominators, poof, 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 right? It feels good to get rid of those denominators, and then I'm just going to write my numerators. So I've got 5x plus 8 minus 7x plus 14 equals 4x minus 12. Okay, and again, we'll just clean this up a little bit. 5x minus 7x, that's negative 2x. And then 8x and 14x, that's 22. I'm sorry, not 8x and 14. Did I say 8x and 14? I just meant 8 and 14. And then this is 4x minus 12. Right, again, we got to get all the x's together, all the numbers together. So what I'm going to do is I'm going to add 2x. 22. And then 4x plus 2x is 6x minus 12. Okay, and then I'm going to add 12 to both sides. So then that gives me 6x equals, this is 34. And then I'm going to divide both sides by 6. So that's 34 over 6. Okay, now that's not enough. 6 doesn't go into 34 evenly, but we can simplify it, right? These are both divisible by 2. So this would turn into 17 over 3, which would be my final answer. And again, last step is to just go back and make sure that that number does not make any of your denominators 0, and it will not in this case. So that's your answer. Okay, so that's solving rational equations. I'll talk to you guys again soon.